Okay, so this is another technique that you can use to divide polynomials. This is synthetic division. We're going to factor polynomials using synthetic division in this video. One thing I will say is that long division always works. The box method always works. Synthetic division doesn't always work. You can't always use it. So there are certain times when it doesn't work, and it has to do with what you divide by. So I'm going to show you this technique, but it works if you have basically a polynomial divided by like a binomial, just like this one. Okay? So let me show you how to set this up. The first thing you're going to do is you are going to write, it consists here of the divisor. Now this is written in factored form. This is a factor. What I want to do is I want to put the 0 in the box. So what makes this factor equal to 0? Well, that would be a -2. So that's what you put there. All right, then what you do on the rest is you just put the coefficients. You just write the coefficients. Okay, I'm pointing like they're little arrows. You don't have to do that, but that's what that is. Right, then you write this line, and then I always put an arrow here, always. It means you just bring down the leading coefficient. That's how you start. Okay, then what you do is you multiply times your 0 and put it here, and then add down. So 31 minus 12 is 19. Right? And then I'm going to multiply -2 times 19 and get -38. And when you add those together, you end up with 15. Multiply again, you get -30. Add those together and you have 0. The last number is your remainder. So the answer will be 6x squared plus 19x plus 15. With a remainder of 0. And you recall that if it has a remainder of 0, then x plus 2 was actually a factor of the original polynomial. Okay, let's try another example. So I'm going to put the factor in here. We're dividing by this, right? So the factor is x plus 5. The 0 is -5. Okay, and then I'm just going to write the coefficients, making sure that I'm not skipping any, 1, 9, 23, and 15. Okay, doesn't take as much room. Draw the arrow down. This goes straight down. -5 times 1 is -5, and you add that, you get 4. -5 times 4 is -20, so you get 3. And then -5 times 3 is -15, added together is 0. So this, and I always draw it like that, that's my remainder. So this has no remainder. So it is a factor. If it has a remainder, it's not really a factor. You can divide it in, but the one that you get, the answer that you get is not a factor. And then, so this is a factor. So it'll be x squared plus 4x plus 3 with no remainder. Okay, so here's a different situation. When you're doing, you have 3x to the third plus 2x plus 7, and you'll notice you're missing a quadratic term. So what do you do when you need to divide? Okay, so first of all, I'm going to put the 0 in here, so this is 1, and I'm going to put a 3 for the cubic, but a 0 for the quadratic, 2 for the linear, and 7 for the constant. All right, so you're going to put the 0 in as a placeholder. So 3 times 1 is 3, add it together is 3, 5, and then 5, and then 2. And so you look here and you say, this has a remainder, so is x minus 1 a factor? And because there is a remainder, it's no. All right, so I'm going to rewrite this. This is 3x squared plus 3x plus 5 plus 2 over x minus 1. Okay, I'd like for you to practice this one in your composition notebook. This is not a very long video, So before you get to class, I want you to attempt this problem. I want you to use long division, and then I want you to rework it using synthetic division, and you should get the same thing. Anyway, I'll see you in class. Have it ready. I'm going to ask for it.